Okay, so let's just do a quick review. The free body diagrams and with F equals ma. I have put on my little screen a problem. It says 2 newtons of thrust being acted upon by 10 newtons of friction on a 14 kilogram object. Solve for all that we can. So the first thing that I'm going to do on here, just because I like to, is I'm going to draw myself a beautiful little free body diagram. And remember, when you draw the box, that represents the object. And I like to put the mass, which is always measured in kilograms, inside of that object. Then we're going to have 2 newtons of thrust, and that's going to be an applied force. And it's going to be acted upon with, it says 10 newtons of friction right over here. Don't forget, we also have our norm, and we also have F of gravity. So we want to add them to the free body diagram as well. Remember, the norm is going to be the support force on there. Now that I have that, the first thing that I'm going to do is I'm going to go ahead and solve for gravity on that. So I'm going to come right here, F of gravity, and remember, step 1 is to write your formula always. So my formula is going to be F equals, or force equals mass times acceleration. Remember, mass is always measured in kilograms, so I'm going to put 14 kilograms there. And the acceleration of gravity on Earth is going to be 9.8 meters per second squared. And we're going to get out our calculators, and we need to plug that in, and we're just going to round to the nearest tenth or one place out from the decimal on here. We're going to get 137.2 newtons. You must add your units on there, or it's going to be counted wrong. Then I'm going to come right back over here to my free body diagram. And because these are equal opposing forces, I'm going to go ahead and add that to my free body diagram so that I know. So I'm going to look up and down. I was given mass and acceleration, so I was able to solve for something. Now I'm going to look left and right. If I look left and right, I see that I'm given the mass, and I see that I'm given 2 forces. So I can probably solve for my acceleration. So the first thing I have to do before I can do that is I need to solve for the net force. So if I'm looking at that, I see that I have 10 newtons to the left and 2 newtons to the right. And that's going to give me a net force of 8 newtons. Make sure you add your direction left. There we go. Now I can take this information and I can go ahead and solve for the other missing variable, which in this case is acceleration. Now I have told you guys in the past, it always helps if you draw your triangle out. Force equals mass times acceleration. And then to see what we need, we know we're given force of 8 newtons and we're given the kilograms of mass, so we're solving for acceleration. So if you were to cover that up with your finger, you would get the formula for acceleration is equal to force divided by mass. And if I go ahead and plug those numbers in with the units, I have to use my net force there. So I'm going to put 8 newtons divided by 14 kilograms. I put that in my handy dandy calculator, and I get 0.57 meters per second squared. If you do not have your units on there, we will count it wrong. So remember, step 1 when you're solving is to write the formula. Step 2 is to plug the numbers in with the units, and step 3 is to solve and make sure you include the units. Like I said, I always find it beneficial when I can that I plug in that and I draw the triangle and turn off anything that I can. Let's look at one more together. Let's say I have a 5 kilogram object being pushed with 7 newtons and 5 newtons of friction opposing. Solve for all that I can. First thing I'm going to do, just because that helps me out, because I'm going to look up and down and left and right, is I'm going to draw my free body diagram. And I have 7 newtons right here acting upon it with 5 newtons opposing. I know that it's sitting on something, so that's going to give me the normal force. And then I have gravity. And notice how those arrows are the same length because they are opposing forces on there. And they're equal. So I'm going to go ahead and start solving for all that I can. Let's start with our net force this time. If I look left to right, I'm giving force and mass. So if I have my triangle again, and if you draw it out one time, you don't have to draw it out every time. I'm given the force and mass. So I'm going to be solving for acceleration. Again, how'd that work out? But before I can plug that force in, I'm going to have to get my net force. So my net force is going to be 2 newtons right. 2 newtons right. And that's why I'm going to have to come up here and plug in for my force. So if I come here, I'm going to get 2 newtons. And the mass is 5 kilograms. 2 divided by 5 is going to give me 0.4 meters per second squared. So that's another answer. And now I've looked left and right. Now I'm going to look up and down. And I'm given, once again, the mass. And I know the acceleration of gravity is 9.8. So I can come right down here and solve for the acceleration of gravity. Right here, not the acceleration of gravity, I can solve for the force of gravity. And if I were to come, my mass is 5 kilograms. And the acceleration is 9.8 meters per second squared. And if I multiply 5 times 9.8, I get 49 newtons. So the force of gravity is going to be 49 newtons. And that's also my normal force that I can assume at this point. Hopefully this helps and gives y'all a little more clarification.